Hey everyone, I'm Nelson Osacky, and today I'm going to be presenting the Android cache fix plugin and why do I need to solve my own cache misses. Before I get into the talk, I'm just going to give a little background on my role at Gradle and why I'm talking about this topic. So I work on the Gradle Enterprise team as a solutions engineer. I was previously an Android engineer just like you. I've worked on large projects such as SoundCloud and Square. I've also worked at small startups that you've probably never heard of. And I'm also a Gradle plugin maintainer. I write the Fladle plugin, which allows you to easily scale your instrumentation tests on Firebase Test Lab. I also write a plugin called the Gradle Doctor, which gives you actionable insights for your build. And that's a link to it. So in my role as a solutions engineer at Gradle, I see a lot of builds. Android builds, Gradle builds, Maven builds, from 10-person teams to 1,000+ teams, and I help these customers improve their builds. I optimize and understand the builds, I help them increase build stability, and of course teach about developer productivity. We're all about developer productivity at Gradle. Another part of my role is improving the Gradle ecosystem. Whenever I see issues with Gradle plugins, open source plugins that affect customers, I go in and fix those, usually performance issues. And then I also meet with Google and JetBrains to help prioritize issues that are impacting customers. And I'll get back to that later on in my talk. So why is developer productivity important? So in Android development, of course this is simplified, but you have feature development, you have tech debt. There's other things too, of course. But if we talk about tech debt, you could also think of it as either you're refactoring code or improving your builds. And I'm here to say that slow builds are tech debt, and it always pays off to work on it. Why is that? Because slow builds are a waste of time. A 60-second waste of time in a build, and if you run your build 50 times per day, and you have 50 developers on your team, that's 42 hours lost per day. If you have a standard 40-hour work week, you're using an entire work week on your team. That doesn't include lost focus, right? We have an ROI calculator on our website. You can plug in numbers and see how much time and money you're saving your team depending on the team size and how often you're running your builds. There's a link to that at the bottom. But my point is that fast builds are very important. In this case, you could hire 5 new people without paying them. You don't have to get a new recruiter or anything like that. You're just an extra 5 developers on the team. And so the other point to this being tech debt is that it's very easy to justify working on build speeds, because if you're refactoring a part of the code base that you're never going to touch again, well, that was kind of wasted time. But if you make your build faster, you're always going to be running the build. So just as a background info on talk, I'm going to talk about build caching a lot in this talk, so it helps to be on the same page. So let's say you have a Java compiled task in Gradle. As inputs, you have your Java source files, you have compiler arguments, you have dependencies. Of course, there's other arguments too, but this is just a simplified version. And then the outputs to the task are Java class files. Now this is, of course, the Java compiled, but any task can be made cacheable. So if you think of these, the source files, the compiler arguments, the dependencies, and other things, those are all part of your cache key. That is a hash that uniquely represents the inputs to your task. And that cache key is what is used to look up the cached outputs in the build cache. So if you have a cache key, you compute that cache key based on your inputs. You can simply grab the outputs, the class files, from the build cache instead of re-executing the task. And that saves you a lot of time. So now let's get back to what is the Android cache fix plugin? Well, it solves misses and issues in the Android Gradle plugin. So now we need to define what is a cache miss, because in the community there's a lot of things. Broken cache, what does this mean? So broken cache can mean many different things, and I've seen it used in many different ways in the community. In this talk, we're going to talk a lot about cache misses, which are when you expect to have a cache hit, you expect to save time, but you didn't get that result from the build cache because the cache key was different. Other broken cache examples could be that you get a cache hit when in fact the inputs have changed, and that's an errored build, right? Your changes are not a part of the outputs. Another example of broken cache could be missing outputs in the build cache, so not all the outputs that were generated by your task are represented in the build cache entry. And yeah, there's many other different types of broken cache issues, but those are just some examples, and in this talk we're going to talk a lot about what cache misses are. So how do you discover a cache miss in your build? The easiest way is to run 2 identical builds and then compare the inputs to each task. So let's say you have Gradle W, assemble debug, and then you run Gradle W, assemble debug. Of course, this is a simplification. Then you could do a task input in Gradle Enterprise. So this is a Gradle Enterprise feature. You highlight 2 builds, and then you click the compare button, and then it'll give you a list of all the differences to all the inputs to every single task. So I'm going to be referencing task input comparisons a lot in the talk. That's how you do them. And I'll give more specific screenshots that you can actually see. This is just an animation of how to do the comparison. So how does the Android cache fix plugin work? So if we start with this task input comparison, this is on the compile library resources task, which is part of the Android Gradle plugin. We have, and this task has a file property or an input, one of the inputs that was on the slide earlier. And this input is using an absolute path sensitivity. Why is this a difference? Why is this a cache miss? So path sensitivity is a way of telling Gradle which part of the file path is considered part of the cache key. So if you have this example, and you have these inputs to the compile library resources task, in this case, this is the directory where your resources are in. When you use absolute path sensitivity, it cares about the entire file path to those files. And this is the safest option, and this is the default whenever you declare an input to a Gradle task. And what that means is that if you run the same build on Jenkins and it has a different user home directory, you are not going to be able to take that output from the build cache. So that's a cache miss. So what we want to do is ignore the fully qualified path. So how do you do this in Gradle? And if I'm a task author, how would I make it so that only the relative path is considered part of the cache key? So let's say we have the compile library resources task. I'm just simplifying it very much. It has the cacheable task annotation to make it cacheable. And you have an input file property, which is the merge library resources dir. By default, this is absolute path sensitivity. So we can make that explicit by adding the absolute path sensitivity annotation, but that doesn't change anything. What we need to do is change that to be relative. So that's as simple as that. But of course, to change it in a third-party plugin, it's a little bit more difficult. So the Android Cache Fix plugin does some workarounds to fix this compile library resource task absolute path sensitivity. So how do these workarounds work? So this is just a piece of code from the Android Cache Fix plugin. And for every cache miss that we have, we describe which version of the Android Gradle plugin it was introduced in. We describe what version it was fixed in. In this case, this issue is fixed. We also have a link to the issue tracker on Google's issue tracker, because we have a collaboration with Google. We report all these issues to them so that they can improve the performance of the Android Cache Fix, the Android Gradle plugin. And then the workaround code goes inside this class. So the workaround I'm about to describe, we call it the 3-card Monty. And there's some other, in case, so 3-card Monty is actually the US English name for this game. In UK English, it's called Find the Lady. And then there's some other languages down there at the bottom. But basically, it's a card game. It's a card trick. I'm not talking about Gradle right now. This is just a card game. You may have seen this at like touristy places and cities. This is a picture of con artists doing this in Potsdamer Platz in Berlin. I gave this talk last week in Berlin, so this was a very relevant picture. So yeah, how does this card game work? I'm just going to play a very quick slide of how this magic trick works.
I was showing someone 3-card Monty. I have 3 cards. The first card is a joker. The second card is a joker. The third card is an ace. If you can tell me where the ace is, I'll give you $1. If you're wrong, you owe me $1. The ace is on the top. If I place it on the bottom, where's the ace? He said it's on the bottom. Wrong, you owe me $1. Try again. He said it's on the top. Wrong, you owe me $1. He said it's in the middle. Wrong, you owe me $1. Wait a minute, you don't even have an ace. Wrong, you owe me $1.
All right, so now what I'm going to teach you is how to do this sleight of hand trick with Gradle, the Gradle Monty. And I will preface this with saying, don't try this at home. So yeah. So first you add a workaround property with a relative path sensitivity to the existing task, right? You can add any inputs you want to any tasks in Gradle. So what you have to do is add a workaround property with relative path sensitivity. Then we set the workaround property with the value of the original property, right? That is the contents, the fully qualified directory, but now Gradle will treat it with relative path sensitivity. Then you set the original property with the absolute path sensitivity to a dummy value, empty value, right before Gradle performs the input snapshotting. And so in this case, when Gradle performs the input snapshotting, it's going to do it on the relative workaround property and the dummy original property, which points to nothing. Then after input snapshotting, you set it back to the original property, and then Gradle executes the task on the original property. So how do you do this in code? So you configure the task, the compile every resources task. You create a new directory property. You create a new input with relative path sensitivity. In this case, it's called .workaround. And then we use this thing called gradle.taskgraph.beforeTask. And this code here will be executed just before input snapshotting. So because this is inside the configuration action, and before task is called on every task in the graph, we have to make sure that tasks are matching. That's why there's the if statement. Then we set the original property with the contents of the directory property we created. Then we create the dummy property, then we set the original property back to a dummy property, which is just a file/dummy on the file system. Therefore, the fully qualified path is just /dummy. And then we add a do first action on the task. So this will set it back to the original value just before Gradle executes the task action. So very simply, this is how you trick Gradle and perform sleight of hands with Gradle. But please don't ever write that code. All you have to do is apply the Android cache fix plugin, and this is actually fixed in Android Gradle plugin 7, which is with a small asterisk, that you have to enable these experimental properties. So Google has been working on this for a long time to enable these fixes to have relative paths, and you have to enable those flags. All right, so next I'm going to talk about the room cache miss. How many people use room in their Android builds? I see a lot of hands up. So let's just explain a little bit about how room works. So room is an annotation processor. You add it to your build just like this. Oh, this is the part where I was going to ask. Okay, cool. So, so let's say you have your app database, right? You declare this in your source code, and then Gradle is going to write some stuff to the build folder, right? That is how annotation processors work. You add annotations, it writes stuff to the build folder. In this case, it's going to be writing the app database to the capt/debug folder, and there's the whole package name there. And then there's this other thing, which is the room schema locations. So the room annotation processor, you can generate schemas in order to test the migrations of your databases. And if you want to do that, you want to have it generate schema, you give it the schema directory. And this projector/schemas has a problem. So where is this, right? This is just in your project directory. There's just a /schemas folder, and it generates these 1.json files. What is the problem with this project directory? Well, as we saw before, that's going to have my user home on my computer. On Bob's computer, it's going to have that fully qualified path. And on Jenkins, it's going to be different. So this schema directory causes a cache miss. And in a task input comparison, so if you run 2 builds from 2 different locations, you'll see this in the task input comparison. So you see the Java compiler arguments are different, and the capped without colon C task has the room schema location with a different value, because that's the string. The string is the value that is different. So how do you fix this? Gradle has a thing called the command line argument provider, which allows you, it basically tells Gradle which parts of the string that you're passing to the compiler argument that you can ignore, or that Gradle can ignore for the purposes of cache and path sensitivity. So you create this room schema location argument provider, which implements command line argument provider. Then you have to implement this interface, which is to return the arguments. So here, we're going to pass in the directory that we want, the schema location directory. And we're going to set that as a property. And then the argument that we're going to return to the compiler is room.schema location, and we're going to pass it the fully qualified absolute path. So that is what this class is going to give to the actual compiler argument. But Gradle will treat this property with relative path sensitivity if we add the annotation. So what Gradle will look at for input snapshotting is this property. And it's also an output directory, so we give it the output directory annotation as well, right? Because it's writing schemas here. Now this is actually not correct Gradle code, which I'll get back to in a second. What's the issue here? But this is how you would solve that cache miss if that were the only issue, which I'll get to also in a second. So how do you use this, right? So instead of passing the argument as a string like this, you instead give the annotation processor options. There's a thing called the compiler arguments provider, and you just add it just like that. And now you get cache hits, right? Sort of. So the issue is that this schema folder, well, it also contains the old schemas. So the old schemas and the new schemas are going to the same directory. What's the issue there? So if 1.json exists and is committed to version control, and then 2.json is written when your schema is updated, that means that 1.json is basically the input, and 2.json is the output, but they're both in the same directory, the schemas directory. So what do? Then you just add the input directory annotation to this property, right? Well, no, you can't do that in Gradle. You can't have a property be both an input and output. It won't even compile, and Gradle will yell at you like this, so that's not good. So how do we solve this? Well, before we solve this, let's just point out one other issue, which is that, right, you can have debug code, you can have release code, and of course you can also have other flavors too. And if they're, if we go back to the capped, right, capped is writing its outputs to a task-specific output directory. But this annotation processor argument is writing to the same folder. So both capped debug and capped release, as well as all the flavors you have, are writing to the same folder. So what is going to be the issue? If you're looking at a build scan, you can just go to the timeline. You don't need this. You don't need Gradle Enterprise to see this. You can just run a build scan on scans.gradle.com, and you filter on the timeline for not cacheable tasks due to overlapping outputs, and then you can see there's 2 tasks here in the list, and build scans will tell you that task output caching requires exclusive output access to the output paths to guarantee correctness, right? Because otherwise Gradle doesn't know which task actually generated the output there. Was it capped release? Was it capped debug? And so caching is disabled for these tasks. So let's sum up the issues we're having here. So there's absolute path sensitivity, there's overlapping inputs and outputs, and it's a non-exclusive output directory. There's also one more issue, which is that capt removes the contents of output directories to the annotation processor. So it would wipe out all your schemas. That's great. That's a lot of issues. So what is the issue really? Annotation processors are not tools to write arbitrary files on your file system. This is what Gradle tasks and Gradle plugins are designed to do. So Room needs to be a Gradle plugin. It really needs to be like a Gradle plugin. This is the only way to fix it. Otherwise, the Android cache fix plugin will exist forever, even if Google fixes all the other cache misses. Luckily, there's the Room schema location workaround in the Android cache fix plugin. Fixes all of these. It does some really crazy Gradle magic and writes everything to task-specific output directories and then merges it all in the end. Gary on the Gradle Enterprise Solutions team wrote this workaround. It's very, very clever. I recommend looking at it if you really want to blow your mind on crazy tricks that you can do with Gradle. But really what we need to do to fix this is to star these issues because we really want Google to fix it. They need to turn this into a Gradle plugin. Yeah, and the other thing to point out is Google does care about performance because Room now has Kotlin symbol processing support. But that doesn't solve the cache miss, right? It's still writing the outputs to the same place. So what's the issue, right? What looks better in a promotion case, right? We all work at these software companies. We know how this stuff works. If you use the new technology to rewrite Room with KSP to improve build speeds, or you fix a 41-star bug filed by the community and turn into a Gradle plugin, this existing technology, that's not so fun. So yeah, really, like, scan that QR code, star that thing, tweet it, hashtag it. Like, we need Google to fix this so we can make all our builds faster. Yeah, I'll just leave it there so everyone can scan it. Yeah, this is a very, I see a lot of builds, and really this is an issue in like over half the builds I see in the Android space. So every time I see it, I do that face palm like that statue. So another thing that the Android cache fix plugin does is fix these types of things. So has anyone ever seen these negative avoidance savings on build scans? What does that mean? Okay, so what that means is that it took longer to fetch the artifact from the cache than it would take to re-execute the task. Why does this happen? Let's go back to what caching is. So let's say you have these inputs, the Java compile task, you have the output, we saw this earlier. Let's say we have a much simpler task, the copy task. It moves files from one place on the file system to another. There's up-to-date checking in Gradle, which just checks if the files are already there in your project build directory. And there's the Gradle build cache, which lives in your Gradle home. These are two separate mechanisms. And the Gradle build cache, all it does is it checks if there's a zip entry with the same build cache key. And then it pulls it back and puts it on your build output directory. So if we go to this copy task, right, and let's say we add some caching to this copy task, it's going to compute a hash based on all the source files that are being copied, and check the build cache, and then grab the source files from the build cache. And so let's focus on what this cache retrieval process mechanism is. So let's say you have your project directory, and you have the build cache. These are two separate things, right? Let's focus on the cache storing and fetching mechanism. So you have something in your build output directory. You zip it up. You put it in the build cache. When you want to fetch it, you grab it from the build cache. You unzip it, and you put it back. What would it take to re-execute this copy task? Well, you just move the files from one place to the build directory. So you can see how caching would slow down a copy task. The other thing is that anytime you change any inputs, it will do the whole process of storing it in the build cache, even if you never retrieve it back from the build cache. So adding caching to to the copy task, even if you never use it, is still slowing down your builds. You're writing it to 2 places now. So, and this is documented in the Gradle user guide. Sync task, which moves something from one place to another. Copy, which copies it from one place to another. If you're zipping something, right, you don't want to zip it and then zip it up in the build cache. Jar task, which creates a jar file, which is also basically a zip, should not be cached. So this bundle library classes jar is basically a jar task, and so it shouldn't be cached. So how do you disable caching? This is much simpler than all the other workarounds. Outputs that do not cache if true. And so yeah, you configure the task, you write it, you can give it a message, this message will appear in your build scan, and that's how you disable caching for these tasks. So that's been an area of focus. So whenever I see a customer with a task that has negative avoidance savings, I go in and I disable it in the Android Cache Fix plugin. And yeah, I found one just the other day. I can't remember what it was, like the data binding class that was in there. But yeah, if you find any of these, please file issues with Google. Also file them in the Android Cache Fix plugin so we can fix it. So the thing about the Android Cache Fix plugin is it allows you to have all the latest fixes for all of the newest versions of Gradle, like all these disabled caches, the compile library resources workaround, across all versions of the Android Gradle plugin. We work with many customers. Some of them are stuck on Android Gradle plugin 3.5, which is 2 years old now. So we want them all to have fast builds. So that's another benefit to the Android Cache Fix plugin. Yeah, these are some other cache misses. But yeah, I think I want to thank the Android Gradle plugin team at Google because they have been fixing all of the issues we report. And there's a list of workarounds, and they get smaller and smaller with every new version of the Android Gradle plugin. And that's really good to see. So how to use the Android Cache Fix plugin? You basically apply it to all your sub-projects, or if you're using a convention plugin, that would actually be the right place to put it. But if you're not, this is how you would do it. The latest version is 2.4.4. So now, yeah, another topic. So yeah, that was done with the Android Cache Fix plugin. I just wanted to point out some Gradle Enterprise Android features that just came out. So we have the slowest test dashboard. You can easily find your slowest tests across all your builds or an individual build scan. And this is a great way to improve the speed of your builds. If you speed up the slowest test, the longest pull, it's going to make your entire build faster. We also have flaky test insights. So whenever a test fails, you can retry it using the Gradle retry plugin. And if it fails and then succeeds during the course of the same build, it'll be marked as flaky in the dashboard. And I don't know how many people here use Gradle Enterprise or build scans, but you may have noticed that you don't get these insights for your Android instrumentation tests. But I'm actually really happy to report that if you're using the latest version of Gradle Enterprise Gradle plugin, you can get your Android instrumentation test results in your build scans. It's in beta, so there's some additional steps to actually put that in your build scan, but feel free to reach out to me and I can tell you what that is. Another thing I wanted to point out is if you want to look at what these features look like, you can go to this website, gradle.com/enterprise customers OSS projects. We're also working with the Android X team to get them to have an open source instance of Gradle Enterprise so you can check it out, see how their builds work and all that. But if you want to see, for example, what our Gradle Enterprise dashboard looks like for Gradle, that's where you'd find it. You can also see it for other projects like Spring. JetBrains has an open source instance as well. They're all on that website. This is just a quick look at what this flaky test dashboard looks like. If you type in that link, you'll go exactly to this dashboard you see here. Yeah, that's the full path at the bottom. So this is basically answering, what is Gradle's slowest test or most flaky test? Yeah, see how it's filtered by mean execution time. And you can also filter by flaky. If you wanted to know what is Gradle's most flaky test, you can just see that on the internet. Cool. So yeah, that's pretty much the whole talk. I just wanted to point out, please star this issue. Did I say that before? If you want more resources and learn about Gradle, I know this was a very in-depth talk. We have trainings on our website, gradle.com/training. We have introduction to Gradle. We have a build cache deep dive training on our website. There's also the Gradle community Slack where you can ask questions to folks at Gradle, other members of the community, so feel free to join. And then one more time, that QR code, because I know everyone loves seeing it. Thanks for coming. If you're interested in a Gradle Enterprise trial, that's the link. The solutions team at Gradle, we're actually hiring across the board at Gradle. Front-end engineers, back-end engineers, solutions, developer relations, everything. And then we have a booth here at DroidCon. Those are the people on our team. Aisha, Ruz, me, and Julianne. Come find us, talk to us. We're cool people. We don't bite too much. And yeah, that's the end of my talk. And yeah, if anyone has any questions, feel free to ask. Oh, wait for the mic.
Is there a case where absolute path sensitivity would make sense? And if not, why not just prevent that from being a possibility?
That's a good question. So the compile library resources workaround, part of the process of compiling it actually writes fully qualified paths into these .flat files that are mostly used for like diagnostic messages and errors in the IDE. But most of the time, if you're retrieving it from the cache, the successful result, you don't actually need it. And in that case, that's why the workaround is there. And that's also why it's taken Google a long time to properly fix it, because they have to remove these fully qualified paths from being written to the outputs. But yeah, good question.
Cheers for the talk, really enjoyed it. Just one question I had with the examples that you were giving. When you were talking about the cache misses and the absolute paths, it was usually because the user had changed.
Mm-hmm.
I was wondering, like, how often or in which scenarios would you have a build being run on the same machine by a different user where you could reuse the same builds? Because I would have thought that your build machine is like, that's Jenkins, and the only person that uses that is Jenkins. And on your personal computer, when you're developing, that would be like single user?
Yeah, this is a really good question. I should have answered this in my talk. So there's two scenarios. One is if you've checked out the project twice on your computer, maybe different branches or using Git worktree or something like that, then you would have different absolute paths. The other one, which is much more common with our customers, is using the remote build cache. So CI executes that task, and then you pull the cache result locally. And so you would not be able to pull that cache result locally if you had absolute path sensitivity.
Cool. I didn't know that was a feature, so that's really cool to find out about remote cache. But yeah, thank you very much.
I think it's raining. Well, anyways, if there's no other questions, thank you very much, and see you around.